You know this forest is full of trees because you can see their green leaves and woody trunks. And you know these animals are deer by the color of their fur and the shape of their body. Similarly, you can identify this sound as a spray can being activated. And you can tell this sound is water coming from a sprinkler. These are just a couple of examples of observations we make every day. In many cases, we can record our observations in the form of data. Let's take a look at some familiar examples of data. At one time or another, you've played a game and kept score. If you're a baseball fan, you may be interested in all kinds of data, such as batting averages or earned run averages of pitchers. These are all data we use in sports. Other examples of data which you're familiar with include your age, your height, and your shoe size. Observations and data are very important in science. Through observing and gathering data, we learn a great deal about our world. During the next few minutes, we're going to explore how observations and data are used not only in scientific processes, but in our daily lives. When you place a tea bag in a cup of hot water, you notice that the water becomes darker the longer you let the tea bag steep. And if you take a walk in the evening as the sun is setting, you may notice that it doesn't get dark all of a sudden, but gets dark gradually. And you may have noticed that if you let your cereal sit in a bowl of milk too long, the cereal gets soggy. These are all examples of observations we make every day. What exactly are observations? Observations are things we observe about our surroundings using our senses. Our senses include those of sight, touch, taste, smell, and hearing. What sense would you use to describe the texture of this tree trunk? You'd use your sense of touch to describe it as feeling hard, dry, and rough. Our senses are very important in making not only everyday observations, but observations in science as well. In both everyday life and in science, it's common to use instruments to make observations. When you use a scale in your home, you're using an instrument to make an observation about your weight. In the science lab, you may use a microscope to make observations about the characteristics or habits of microorganisms. Let's take a look at some different types of observations. If you describe this rose as being red or cake as being sweet, you're making qualitative observations. A qualitative observation includes descriptions of sights, sounds, smells, or textures. You observe. Make a qualitative observation of this tennis ball. A qualitative observation would describe this tennis ball as being round, yellow, and fuzzy. You also might say that it bounces and is relatively light. The other type of observations we can make are quantitative observations. Quantitative observations are based on numbers. For example, instead of saying it's very cold outside, we can say that it's minus 18 degrees Celsius. Or instead of saying it's a long walk, we can say it's 15 kilometers. Quantitative observations tell us how much and quite often involve measuring. Every day, you measure things. One of the most common things we measure throughout the course of a day is time. When you cook, you measure ingredients. And if you play sports, you often measure the number of points in a game, or measure the distance of a race, or the distance an object is thrown. Measurements describe an observation by comparing it to standard units such as minutes, grams, or yards. Measurements include both a number and a unit. In science, thousands of different kinds of instruments, from simple to complex, are used to make measurements. Measurements of length, volume, mass and weight, and temperature, to name just a few. In making measurements, a number, along with the unit it represents, provide a quantitative description of the thing that's being observed. You decide. What is data? Data consists of recorded observations. These observations can be in the form of qualitative or quantitative data. Data is incredibly important to all kinds of scientists. Data is very important because it not only describes observations, but it shows relationships and identifies patterns. In short, data can teach us new things. You know that ice melts into liquid water, and that when water boils, it bubbles and produces steam. These processes can be qualitatively observed and described with words. But how can you quantitatively describe these processes? The most logical thing to do is take temperature readings of these processes using a thermometer. We'll begin our experiment with a beaker of ice placed over a burner, and we'll record the temperature every 2 minutes. To organize data, scientists often use data tables. A data table, like this one, is a simple chart that often has labels pointing out where recorded data should be logged. The data table for this experiment has time in minutes on the left side. We'll take temperature readings every 2 minutes, which will be recorded in the second column. In the course of our experiment, it's important to take readings exactly at 2-minute intervals and to read the thermometer as accurately as possible. After several minutes, you can see the ice melted at 0 degrees Celsius, turning from solid ice to liquid water. The information here in the data table shows this process. After several more minutes, the water gradually got warmer and eventually boiled at 100 degrees Celsius. Have you ever heard the expression that a picture can paint 1,000 words? Well, it's possible to make a picture out of data. There are many different pictures or ways that data can be displayed. Graphs are one of the most common ways to display data. A graph is basically a picture of data. Graphs illustrate how one set of observations compare to another set of observations. Data recorded in data tables can often be put into a graph, making it easier to see the relationship between variables. Let's use our data from the experiment demonstrating melting and boiling to make a graph. We can compare the variables of time in minutes, which we put along this axis of the graph, and compare it to the variable of temperature, which we'll put along this axis of the graph. All we need to do now is take the data from the data table and graph it. This is done by taking each data point and matching it up with its time and temperature and placing a mark on the graph. Let's now take a look at how this graph looks when all the data is entered. After we enter all the data from the data table, we can connect the data points with a line. This type of graph is called a line graph. Line graphs are very common and are easy to understand. This helps us to quickly see change and patterns in data. Line graphs are particularly useful in showing changes over time. This line graph, for example, shows worldwide population growth over the past 2,000 years. And this line graph illustrates the average monthly temperature of New York City during the course of a year. Another common type of graph is the bar graph. In bar graphs, the lengths of the bars are used to represent data. A numerical scale on the left axis allows the bars to be compared to values. Each bar on the graph represents a data point. The data from our melting and boiling of water experiment can be placed in a bar graph to look like this, where temperature in degrees Celsius is on the left axis and time in minutes is on the bottom axis. This bar graph shows the average temperature in the month of January for 5 cities in North America. You decide. How could we change the graph to compare January temperatures to July temperatures? All we need to do is to place the July temperatures next to the January temperatures for the correct city. This type of graph is called a double bar graph. A double bar graph shows 2 sets of data. The last major type of graph we'll discuss are circle graphs. A circle graph, sometimes called a pie chart, shows how each group of data relates to all the data. Each section of the circle represents a different type of data. In this circle graph, titled Land Use in the United States, each section represents a different type of land use expressed as a percentage. All the percentages add up to 100%. Whereas in this circle graph, each section represents a type of energy source. As you know, it's possible to take your body temperature with a thermometer. We can take this person's temperature every 3 hours for 48 hours and record it in a data table, and then graph it in the form of a line graph. You observe. What pattern do you see in this data? From looking at this data, you can see that this person's temperature rose and then gradually decreased. From this data, you might conclude that this person had some type of infection. Analyzing data is a very important process and an important step in understanding the story behind the data. Scientists exert a great deal of effort identifying patterns and trends in data before they draw conclusions. In many cases, they need to repeat experiments to gather additional data or even revise their experiments. It's important to realize that many of the advances in technology and science are the result of the people observing, recording, and analyzing data. During the past few minutes, we've discussed observations, data, and the display of data. We discussed some of the ways we make observations every day and how we use our senses to make observations. And we saw how qualitative observations are used to describe things that we hear, see, smell, or feel. Quantitative observations, on the other hand, are based on numbers. We briefly explored how quantitative observations are frequently based on measurements. Measurements include both a number and a unit. We investigated the importance of data and saw how data can be recorded and organized in data tables. Some of the ways data can be displayed was explored. Special emphasis was placed on the importance of graphs and how they can be used to visually represent data. The three main types of graphs included line graphs, bar graphs, and circle graphs. In conclusion, the importance of data analysis in identifying patterns and relationships in data was stressed. So, the next time you observe something unusual, weigh yourself on a scale, or see a graph, think about some of the things we've discussed during the past few minutes. You just might think about observations and data a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. We observe things using our. Number 2. A. Observation describes sights, sounds, or smells. Number 3. Quantitative observations are based on. Number 4. Measurements include both a number and a. Number 5. Consists of recorded observations. Number 6. This chart is called a data. Number 7. A is a diagram that shows relationships between variables. Number 8. This is a graph. Number 9. This is a graph. And number 10. Data identifies patterns and trends.